1, 2, okay. So we start because I've got a lot to tell about. This is a presentation about web application security. And I'm not going to talk about web application security because I'm taking into account you already know about web application security. I will go very fast through what cross-site scripting is and through an SQL injection. Why? That you at least have the base knowledge. My name is David Tillemans. I work for Smells as an application security analyst. I've got now 5 years experience in breaking into web applications. Allowed breaking because I'm an ethical hacker. But my background is in programming. So I used to be, a C++ programmer for 9 years. And I'm now a Java programmer for around 5 years at Smells. So what we are going to talk about here is not really about web application security, it's about the automation of web application security itself. So how can we automating testing of applications? And probably you already know some tools to test the security of a web application. The most known tools are static source code analyzers, and I will go through them. And then I will explain a tool from OWASP, Zed Attack Proxy. And Zed Attack Proxy is a web application scanner. So that will go through your web application, we'll try to go through your web application, and we'll try to find security patterns. We'll try to find security bugs in your web application. And those scanners are normally made to be standalone. But Zaproxy has got a cool feature, which is it's got a REST API. And through that REST API, I can steer Zaproxy itself to start scanning the web application. And my first question is about this: can we really automate these tools? And, we can, and we succeeded. But to do automatic security testing, at least you need source code. Because in source code, you have all those, you don't have all those security bugs because nobody writes security bugs. And very important, if you want to do web application scanning, your application has to work. Not whole your application, at least a part of your application. And I use Selenium tests for the functional part. That's my disclaimer, because I'm going to show a tool, web application scanner, which is illegal to use except if you've got a lawful authorization to use it on that application. So you cannot come afterwards to me, I saw a guy about web application security and he showed me some tools and it was very nice and I tried to on your Google website. And if you then come into trouble, you get into real trouble. Because in Belgium, there is even an article about web application security. Hacking is illegal in Belgium law. So beware. Some security myths, which I want to talk about. A lot of web applications, when I'm starting at the Smells, a lot of guys told me, we've got a firewall in place. Why do we need web application security? Well, a firewall is to protect your network. It's not to protect your web application. A firewall doesn't stop your bugs in your web application. So for a web application, an attacker seems like to be a normal user. Okay, the management says, we will put SSL in front of it. Well, one way, I'm not talking about two-way SSL, because two-way SSL, that identifies the user, but one-way SSL on the server side, it guarantees confidentiality. It guarantees that your username and password is sent securely to your web application. But again, an attacker is also going to use that SSL tunnel. And is also, for the application itself, an attacker is going to be like a normal user who's doing a whole lot of requests to get into that application. So these things won't keep an attacker out of your web application. SSL is even getting worse, because with SSL, if you terminate your SSL very badly, even your intrusion detection systems won't see those patterns of that attacker attacking a web application. Because intrusion detection systems, they check on those patterns when an attacker is attacking a web application. And then at last, some application frameworks. Well, I had some discussions, not with this framework, I had some discussion with the developer one day. Well, SQL injection, it can't happen to me, SQL injection. I'm using Hibernate. True, if you're using Hibernate or any kind of ORM correctly, you cannot perform a SQL injection. But there are always workarounds. There are always workarounds in those ORM to really write SQL into the code. The biggest problem with SQL injection, I'm going to explain what the SQL injection is string concatenation. So I used the OWASP top 10 as a reference. I like to work with the OWASP organization, and I would like even that all of you would come to those meetings of OWASP. We've got an OWASP Belgium chapter, and I would like you to invite all of you to go to these meetings, because those meetings are full with security people, not with application developers. And those meetings mostly go about application development. So this is the top 10. I'm going to talk about injection, cross-site scripting, a little bit about cross-site request forgery, and sensitive data exposure. Why? Because those 4 patterns I'm able to detect automatically. Broken authentication, insecure direct object reference, go and look it up. Security misconfiguration, some scanners are able to check that. Missing functional level access control, using known vulnerable components, unvalidated redirected forwards. Well, those patterns, you need to have somebody behind the application itself. It's very difficult for a scanner to check that. So what's a SQL injection? Well, I've got here a nice user who's going to log on to that application. So we send his username and password through an SSL channel. Then this username and password is converted to a SQL command, which probably everybody knows. This SQL command is executed on the server, and then your application do a fetch first, and it will respond with John, and the guy is logged on with a welcome page, John. Cool. What does a hacker do? Well, he sends the user, he doesn't care which kind of name he uses, and then he chooses a password. Well, from a security consultant, I have to say, well, that's a very good password, because that's a very strong password. He's using characters, numbers, and strange characters. Well, that's a very good password. But nothing is true. Because if now somebody is concatenating that password in that SQL command, you see that first quote close the quote from the password. And then you get or in 1 equals 1, and that is true. Now, the database will respond with all users of which are in the user table. Well, I take ARM because I take a SQL database which keeps the alphabet order. 2 A's, and then it enters as welcome Aaron. Well, there is another user which starts with an A, which is much more interesting, and that's admin, of course. That's a SQL injection. Cross-site scripting, what's that about? Well, all browsers today, they have JavaScript. Well, I take a forum, And you post, a guy posts on his forum, well, I'm coming home at 5 o'clock. I stop working at 5 o'clock and I'm coming home. Okay. His wife looks at the forum and says, oh, wow, cool. He's coming home at 5 o'clock. That's nice. I will make him a nice dinner. So, the hacker and the victim, what does the hacker do? Well, he's found a cross-site scripting vulnerability, so he enters in the forum a script, well, the tag script, and then, well, let's take a function because that would make too much place on that slide, which will steal all the passwords of the victim. The victim checks his forum, and now he will download that script, and that script is not visualized, but is now interpreted by the HTML page, and the passwords will be stolen. Damn. That's stored cross-site scripting. Stored cross-site scripting is very, very bad, because that stays into the database for a very long time. Well, the rest of the life if you have bad luck. Well, you can tell me, well, what's my risk? What's the danger about stored cross-site scripting? Well, you are annoying your users. That's the first danger. Okay, you don't lose your valuable data of your company. But if Google or another Firefox or well, Internet Explorer doesn't do that well, but okay. If they found out that you're distributing malware because they were able to inject a script into the site, well, next time your users will log on to your site, you will have a big red screen which says, this site is distributing malware. Not a good publicity for your company. Reflected cross-site scripting is completely different a little bit. Reflected cross-site scripting is about error pages, mostly about error pages. There are a whole lot of other kinds of reflected cross-site scripting, but the most easiest to explain reflected cross-site scripting is through error messages. So, take a guy, send me an email, yes, those phishing emails are sent to everybody. Probably you already had some kind of those mails. Well, I've put the link into the mail itself. Well, today we use HTML mail, so you don't see those links anymore. And we know if this link is still in the site, well, normally you read until here. And if you trust that site, well, then you click on that link without a problem. So the victim clicks on the link. That HTTP request is sent over to the server. The server says, what is that guy giving me? Script password I don't understand. And you're a very good programmer, so you want to be very user-friendly in your program, so you create an error message. Well, error. And then he says, the reason is you gave something which I don't understand, so the script steals passwords. Again, this script is not visualized, but it is executed by your browser, and then those passwords are stolen to your Sensitive data exposure. Well, I'm going too fast. Sensitive data exposure is typically cookies. Sending cookies. If you're not taking care about your cookies, and you've got a secure part and an insecure part, your domain cookies will be sent on the secure part and the insecure part. If you've logged on, if the person is already logged on, he's gone from the secure part to the insecure part, then a guy who sniffs the network is able to steal that cookie, steal the identity, change the passwords of that person, and that person is unable to log on to his website anymore. Error messages. Well, I know you need, as developers or architects, you need those error messages. You need those stack traces in Java because you have to find the problems in your application. Well, from a hacker point of view, well, I need them also. Because error messages will give me, well, which kind of framework you use. If I can find out a lot of similar error messages, I can find out the version number of the framework. I can look up the vulnerabilities of the framework, and then I can try to hack into the system. I've seen error messages with SQL commands. I've seen error messages with complete PHP pages. Well, I've seen all kinds of error messages. Very interesting to hack into an application. So in production, try to catch those error messages. And the last one, cross-site request forgery. Well, that's a nasty one. But luckily, all the good frameworks are now solving this problem. Well, cross-site request forgery is something like session writing. So you've got a person which is already online on her bank. She is authenticated. And then she wants to, the hacker, he knows that web application also very good because he's on the same bank, for example. And he knows how to perform transactions with his application. He knows which kind of commands he has to send to the application server to perform a transaction. And then he creates a GET request instead of a POST request. And well, I read a whole lot of Java code, and I know that mostly the GET request and the POST request, they are pointed to the same function. So it will do directly the same thing. He will perform a transaction. This is sent over to the web server. The web server clicks, well, she clicks on it, and the web server will respond with, "Whoa, I've performed the transaction," and the hacker is 10,000 euros richer. Well, today this is not possible anymore. Your banks, well, banks in Western countries protect against these kind of attacks by using view states, extra confirmation to perform the transaction, and other kind of systems to protect against cross-site request forgery. So these are about the attacks I'm going to demonstrate. Well, not really demonstrate. I'm going to show you how to protect against. A little bit about secure development lifecycle. Well, in the secure development lifecycle, you need to get some steps done. So you need to establish security requirements. And this is, well, I'm going to be very fast about this because I want to give you a demonstration. This is paperwork, mostly. In rational unified process, this is paperwork. And then you get into the coding part. And here you can already start using static analysis tools, static source code analysis tools to detect security problems. And then you go into the testing part, and then you can perform penetration and also automatic penetration part. And if you want to do it in an agile way, I think you can also perform it in an agile way. You just switch around a little bit the phases. Findbugs. Well, Findbugs is a source code analyzer, and I love it a lot because it's got a nice user interface to work with. But Findbugs works on Java bytecode, so your code needs to be compiled, otherwise it won't work. And it searches for bug patterns. And it will find a whole lot of false positives. Well, sorry, you have to go through it. And you've got an Eclipse plugin, which is very nicely to use, and I will demonstrate it. But you've got one small disadvantage. Almost all security patterns, no, all bug patterns are enabled. Let me show you what I'm talking about. So this is PMD, this is Findbugs, and I've got a very bad application. I took WebGoat. WebGoat is it's a vulnerable application, specially made to play around with, to learn about XSS and other kind of patterns. So I do a Findbugs, people already knows about it. Now we wait a little bit. So it's getting all the class files. It's looking at the abstract syntax trees, looking for bug patterns. And damn, it only found 69 bugs. I say damn because normally when a legacy application, you find something like 17,000 bugs inside that application. So, though this is a vulnerable web application, it is well written. Though, let's have a look at those bug patterns anyhow. So, well, call to a static date format, I don't care. That's not a security problem. Oh, an empty password database. Well, that could be interesting. So we're going to have a look at it. Oh, yes. It finds an empty database password in the code. Not good. You don't store passwords in the source code. Well, yeah, okay. That can be a little bit of a problem. This one, well, we can ignore that one. Oh, there's another one. Where is it? Yes, this one. Why don't they call it SQL? Yes. Why don't they call it SQL injection? Damn it. They give it some strange name. So it says non-constant string passed to execute on an SQL statement. Well, that's a SQL injection. That's the problem. That's the SQL injection he has found. There it is. That's a string concatenation which we are looking for. Oh, it finds SQL injections. That's interesting. And to be honest, it does it very nicely. It does it very well, if they look like that. Another security problem, but not a high one, that's this one. I don't understand why. I find it in every code. Shouldn't say that. So we've got here a username length. Oops, sketching this. So you've got a username length, and it's using it to see it's bigger than 0, and then it checks if the username is null. Why? Very strange. So probably if the username is null, you will get a nice stack trace. Very strange. So these are patterns which I only filter on. I will have a special profile, create a special profile, only for security patterns. What we don't see here are cross-site scriptings. No, that it won't find. That I will. I'm going back to this SQL injections. Where is it? Non-constant string passed. Okay. It will find these kind of SQL injections, string concatenation. If your developer is putting here function calls to other kind of functions to create a criteria stuff, then it won't find those SQL injections. But they will be in there anyhow. Okay, so what do you do with your Findbugs? Well, I advise you to, only for security reasons, enable these patterns. Well, these patterns may expose internal representation by returning reference. That's mostly for library, when you're developing Java libraries. Those are obligatory, of course. Those two, SQL, non-constant string pass to execute, SQL prepared statement generate from non-constant string. And then you've got two XSSs, and then you have to be very lucky to find them. We've already had some luck that we found cross-site scripting through the static source code analyzer. And then you've got those very strange null pointer stuff, which creates stack traces. So I advise you to create a profile, especially for security, in Findbugs with only these patterns. Let me look. And you do that somewhere in Eclipse. You can take the preferences and you go to Java, and then you go to Findbugs, and then you can, here, you see it's enabled, everything is enabled, and you can only choose the ones you need. And then you've got a nice profile. And then you get a whole lot of less problems. Because if you're going to show your developers too much problems, they just won't start fixing all those problems. Okay. Next one. So I gave you a demonstration about how Findbugs works. PMD. Well, PMD is a nice, also a static source code analyzer. And this one, it runs on the Java source code. So this one is creating an abstract syntax tree themselves. I have to say, I'm not too accustomed to use PMD because I have more investigated Findbugs. Maybe next year I can talk about PMD. The biggest problem is there are no security patterns built into PMD. Luckily, and I saw them once in Belgium, the company Gotham Digital Science has some open source rule sets for SQL injection and cross-site scripting. So you can check those rule sets out. I haven't tested them myself yet. When I looked up the security patterns for PMD in Sonar, because in Sonar you've got a special security module, I saw that these ones were enabled. So you see, avoid printing stack trace, avoid throwing null pointers for stack traces, do not call system exit. That are not really security patterns. That's all to prevent, how do you call it? It's to prevent stack traces. So, and now I've got a very nice demonstration because PMD, that's nice. So I'm going to clear my violations. Luckily, it's very fast. I'm going to choose the properties of PMD. PMD. Select the rule working set. Nope. Browse, select the rule set. I'm going to say all of them. Okay. Yes. It's fast because I've got a very fast computer and I've got an SSD inside. That I can tell you. I've tested it on other computers. This can be very, very slow. So, violation overview. Well, let's have a look. Well, if you go to your developer with these kind of violations, he will just not start fixing those problems. These are too many to start with. I mean, we're talking about 10,000 violations. And even you probably don't understand which kind of violations you're talking about. So, if you want to start with security patterns, you take only the one I mentioned. Where is it? Go to project settings. And I take only the security ones, that are those 8 ones I showed you. Yes. Normally it should be way less. Okay, Murphy's Law is still, didn't update my site, so I have to do clear violations. Clear violations review. Yeah, now it's updated. So you see, now, I have to say those open source tools are not always that nice to use, but there's way less of violations now. And now you can at least start filtering out which kind of violations you want to use, or which violation you want to solve. At least it's less work. Yes, as a security analyst, I sometimes go through those 17,000 bug patterns. So that's about source code analysis. So my conclusion about source code analysis is, well, PMD, certainly Findbugs, it will help you to find SQL injections. I can already say to you, finding SQL injections is very hard, certainly for scanners, because it depends on the kind of error messages you are showing. If you're showing an HTTP 500 message, well, that's okay, because that we can detect. But if you're just showing a page, okay, you didn't perform that well, that SQL command, and you catch those error pages and you send back an HTTP 200 with an error page, well, it's for those scanners, it's very difficult to detect them, which is good. But on the other side, that SQL injection is still in there. Okay, Zed Attack Proxy. Zed Attack Proxy is an OWASP project, which I love a lot. It's an intercepting proxy. It's a proxy, and a proxy is something which you put between your web browser and your web application. And then all those requests are sent through that proxy, and it will record all those requests. It has a spider, and a spider, it will try to follow all the links, but still it will stay into the domain where he is scanning. And most important, it's got an automated scanner, which I like a lot. It's got forced browsing. That's more for manual reviews, because forced browsing is will trying to find admin pages and other kind of pages which have a fixed name, certainly used in CMS systems. It has a fuzzer, typically used for manual reviews, dynamic SSL certificates, smart card and client, blah, blah, blah. It's got WebSocket support. You can extend it through using of scripting languages. There are guys who are writing plugins in Python. It has a plugin hack support, so you will see it. You can send in the link and then start hacking that URL. And most importantly, it has authentication session support, cool, but most importantly, it has a powerful REST-based API. So you can give it the commands to perform automatic testing. Well, so this is what it looks like, Zed Attack Proxy. So this is the plug and hack. So you put in the URL and you let it go to the site. So let's have a look. Here it is, Zap. Now I'm going to get into troubles because the screen resolution is a little bit too small. Okay. So I could enter in here localhost, blah, 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 and then to that URL, it will automatically spider and attack the application, but that's not the reason. The reason is I made some Selenium tests in WebGoat. So these are my normal Selenium tests. I will take one which gives you a nice result. I've made a Selenium test, reflected XSS test. The reflected XSS test looks like this. HTTP, Google, HTTP, /local /webgoat. Guest. If you ever need to log on to WebGoat, you know that the username password is guest. Okay, start WebGoat. So I reflected cross-site scripting. You showed it in the slides. Where is it? Cross-site scripting. Reflected cross-site scripting is over here. I put in here FFFFF, and then you see, well, you entered blah, blah, blah instead of the, if I put in here a script. Then it says, okay, congratulations, but normally it should show me a script. No, it doesn't show me. Yes, normally it should. Works better with Firefox. Okay. So I've got a Selenium test, create a Selenium test. Run as JUnit test. There it goes. Which does the same actions which I've done just then. No, it doesn't do the same action. It's really a functional test. So I just went around that page like a functional test, and I test the error message. If the error message is nicely displayed, but I didn't put scripts inside of it. Okay. I also made an integration test, which is just completely the same, except it puts everything through Zaproxy. So now you see no sites. There it goes. And now you see it captured all those requests. And already with the passive scanning, he finds some alerts, which probably will be some stuff missing. Okay, and now as an application developer I can say, okay, I've done this test. Good. Why don't we go and scan this site? Active scan. There it goes. So it's scanning that site. We already see red flags, and you know, red flag is never good. So normally it should give me a cross-site scripting. Okay, let's have a look at the alerts. So we found 2 alerts, a reflected cross-site scripting, which, yeah, it was a page of reflected cross-site scripting, which is normal. Zaproxy is very good, well, not say very good, it's good in finding cross-site scripting, really. If he finds a cross-site scripting, you can be certain it is cross-site scripting. So if you go to the page, it does a request with, then we have to look for the where he has put the script. It has a post. If we could look in the body, in the response. Okay, here is it. Well, the resolution is a little bit too small. So here is the cross-site scripting. He's trying to inject, and then somewhere in the response, we have to find that cross-site scripting. And then, well, here it is. Here is the cross-site scripting. So, and then you can show to your developer that you've got a problem with cross-site scripting. Zaproxy is very good at it. So, okay. I showed you how you can do that manually. But you see, I've already put some tests inside of the application. Now, I'm not a top Java developer, so I made for every test, I made an integration test. And that integration test, the only thing which it does is it initializes a proxy. It initializes this proxy. It reads out of the configuration file and initializes the proxy, and then it goes through the proxy, and then it will go through Zaproxy. Okay, so we went further about thinking, how can we automate this everything? Cool. So David, me, has written a Maven plugin. And this Maven plugin will start Zaproxy and at integration tests, everything will be run through Zaproxy, and then it will send commands to start the scanning part. I hope this works. It's always a big risk. So that's almost some tests which I'm doing. You can find this on Google Code, Zap Maven plugin, so you can download it. It's open source. Everything is open source over here, by the way. So now it did all the functional testing. It didn't do any attacks yet. I didn't test that application with really attacking the application. I just did functional testing. Now it's starting the Zaproxy. You can now also start Zaproxy as a daemon. Simon Bennett, the writer of Zaproxy, has confirmed me that you can start as a daemon. And now it goes through the Zaproxy. So it's redoing all those tests, but now it's going through that proxy. And he's recording all the requests inside Zaproxy. Because if you can teach Zaproxy, the web application, it will find much, much more than if you don't teach it. The spider is not that good. my experience with all those kind of scanners, those spiders are not that good. So teach those applications, those scanners, your structure of your application, and they will find much, much more problems in your web application than if you don't teach them. And now you have to wait for around 5 minutes. So you don't see anything too much right now because it's sending commands. The Maven plugin is sending commands to the Zaproxy through the REST API to attack the application. And I know it's working because I see test remote file include, and then I said test redirect strength. So it's working. And these are the messages, the info messages from Zaproxy itself. You see some tests will take a little bit more time. These are the SQL injection tests. Now, if you combine this everything into all those tests, either side, the security tests of Findbugs and PMD, and then afterwards the web application scanner tests of Zed Attack Proxy, I think you already have a good automated coverage. Come on, when does it say build successful? Because I saw that with Findbugs, you can even create a site. You can do Maven site. Yes, I'm not that a good Java programmer because I found that out yesterday. That you can do a Maven site and you can create a site with the result of Findbugs and the result of PMD. If you have to go through 17,000 errors, people just don't want to do that. If you go through 1,000, that's still a lot. If you go through 100, then you can start fixing those problems. Build successful. So now it found some cross-site scriptings and even 2 SQL injections. Why has it found SQL injections? Because I functionally tested those screens of those SQL injections. So this is still in, how do you call it? This is still in its child's shoes. It's still a very initial stage. I was thinking about putting Zed Attack Proxy, its result, into the site phase of Maven, so to create a part of the site with the result of Zed Attack Proxy. I would love to have a Sonar integration of Zed Attack Proxy. If somebody is willing to create one, please contact me or contact the guys from OWASP Zed Attack Proxy. I would love to have an integration in Sonar. And, well, what about agile development? Because, well, you've got to need a working application. Well, I already found a guy who is using not Selenium, but gbehave to do the functional tests, and then with the Zed Attack Proxy to the security test. So already you can probably integrate it in test-driven development and behavior-driven development. So these are the links. You can hopefully download the PDF from the Devox site. These are all the links with all the tools you can use to set up automatic testing for security. And please come one day to the Belgium OWASP chapter. It's always free. Some books about secure development lifecycle. This one is great, but certainly based on rational unified process. This is from Microsoft. Well, this is really good. Even if it is from Microsoft, it is good. They know how to create secure development. You don't believe it, but they know how to build secure applications. Some reflection. What I've shown to you, it's already a start, and it's a good start. But there also exist commercial tools. I'm not going to mention any commercial tools right now. If you want to know some names about commercial tools, you can ask me on the site or on the stand of Smells. Commercial tools, they are really more integrated into their environment, built environment. But you need to use their built environment. Hopefully they're using Maven. Secondly, they perform way better than my open source tools. Those source code analyzers of those commercial tools, they are really good. Every time I evaluate one, I'm really impressed about what they're able to find. But they are expensive. But they are good. They are better than Findbugs, sorry. The best results you've got with manual results. That's hire me. I'm not for hire because I work at Small, so hire guys like me. Then you've got the best results. The biggest problem is we are very expensive. Probably doing one review, you've got 2 of those kind of tools probably. And it's not constant, so you don't have to build it in your application review. Or every year you hire me, of course, that's also the solution. And in the build process, it's very late. So if you have to go in production in a week, and you hire such a guy, and he says, yeah, ooh, you can't put that into production. There are security bugs inside of it. Then it's mostly too late. And it's so, yeah, don't you have a solution to hide those bugs? Well, no. So I'm now open for questions, but like I said, I won't mention any commercial tools. Okay.
Hello?
Yes?
So, is it possible to run this on Jenkins?
Yes.
Okay.
Yes. Yes, yes, you can run this on Jenkins. We've already tested on Jenkins. We are only scared about Zaproxy. If you've got an application which is very big, Zaproxy is starting to consume a whole lot of memory because it caches all those requests to analyze them for cross-site scripting. But you can run it on Jenkins. We've already done it. Only we don't have a reporting tool yet. Well, we downloaded the XML files and we looked in the XML files. Any other questions? Thank you.